Let me just check. Yes. Okay. Let's begin. Right. Okay. So let's begin, and it's my great pleasure to welcome you all for this today's webinar, which we have entitled Memories and Dreams. This is the second lecture in this series, this webinar in the series that we have started for the benefit of students of the Department of Chemistry, Savitribai Phule, Pune University. As you all know, we are going through a very unusual phase in terms of the COVID-19 and its after effects. Especially the students, the education has been hampered a lot, especially subjects like chemistry, where practicals and whether experimentation plays a very important role, which we have been missing, that has slightly disillusioned the students, and they are a bit worried about what future holds for them. And to motivate them in this situation, we thought that it would be a very good idea to invite our esteemed alumni to motivate them, tell them that the things are not that bad as they think they are, and to tell them about the path that they have carried out, again under odd circumstances. And our today's speaker is one such person who has several laurels to his credit, and we are proud to say that he is our alumni, and that is Dr. Vilas Phule, who did his master's from the University, the Department of Chemistry, and also his MPhil degree from university. He has a very illustrious biodata. I'm not going to read all of that, but I would just like to mention couple of important achievements. He is presently the Professor, Davidson School of Chemical Engineering, Purdue University, West Lafayette, and a Purdue faculty scholar. He has a very illustrious career in terms of, after completing his master's from Pune University, MSc, and that too in inorganic chemistry with specialization, MPhil in 1999, and then he did his PhD in Israel from University of Bar Ilan, Israel, in 2005 at the Center for Advanced Materials and Nanotechnology. And from there, he went to do his postdoctoral fellow at first in Israel, then at Argonne National Laboratories in the USA, then was a material scientist in Argonne National Laboratory working on lithium battery materials group, is a visiting faculty, International Center for Materials, Nanoelectronics, Nanoelectronics, National Institute of Material Science, NMIS, Tsukuba, Japan, and has several other awards. I can name several of them. He's elected chair of Purdue Sustainability Committee, fellow International Association of Advanced Materials, Sweden, Purdue University Outstanding Engineering Teacher, and I can go on and on. But one of the most important ones is also Nanoelectronics, National Institute of Material Science, NMIS, Tsukuba, Japan, and has several other awards. I can name several of them. He's elected chair of Purdue Sustainability Committee, fellow International Association of Advanced Materials, Sweden, Purdue University Outstanding Engineering Teacher, and I can go on and on. But one of the most important ones is also Japan, and has several other awards. I can name several of them. I think we have stopped here, is it?
Yeah, it is repeating your voice.
Repeating. Yeah.
Voice is not clear.
I think it's repeating the.
Did you open it twice?
I don't think so. 1 second, I'll just. Yeah. I think we have stopped here, is it?
Yeah, it is repeating your voice.
Yeah. I'll see. Repeating.
Did you open it twice?
I don't think so. No. Yeah. Is it repeating again? I see. I'll just close it once and see. 1 second, I just checked out. Is it repeating again? I just close it once and see. 1 second, I just checked out. Is it? Yeah. Now is it audible?
Yes, sir.
Yeah, it is.
Okay. Okay. I think there's some problem. Yeah. And yet, yeah, and the Guinness Book of World Record for the fastest time, 8 minutes 36 seconds to arrange all the elements of the periodic table, was the is it audible? Important, yeah.
Yes, sir.
Okay. That's fine. Yeah. And yet, yeah, and no, it's repeating the same thing. The Guinness Book of World Record. Yeah. Right, now it's fine, right?
Yes.
Yeah, now I think it's visible. Okay, so the Guinness Book of World Records was the height, and we are very pleased to know that, and we thought that it would be a great idea that he motivates our students. And his other records, he has several publications and nearly 13 patents to his credit, and I'm sure most of them are being commercialized and has involved technology transfer, and he has very innovative ideas, works on very relevant topics, and is also working with the Pune Municipal Corporation on several aspects. So it's a great pleasure for me to welcome Dr. Vilas Phule to give his talk, which is also very nicely entitled Pune University to Purdue University Voyage via Israel with Innovative Imagination. Dr. Vilas Phule, please.
Thank you, Dr. Kumar, and all my colleagues. Indeed, a great pleasure today to talk to you and take you through my life journey. Could be part of the journey, and there might be still left over where we can do, and you will be seeing further things. So here behind me, you are seeing the picture. It is written that 150 years of giant leaps. And that shape you see is Neil Armstrong. Neil Armstrong was the one who went on Apollo 11 on moon in 1969. He's a graduate of Purdue University, where I am teaching, and I am also a faculty of materials engineering, chemical engineering. Today is a very auspicious day in United States as we are celebrating Christmas evening, where the Christmas brings joy for you, the gifts of happiness, good health, and joy. So with that, I will begin the seminar where you will be seeing the pathway I followed, and that will encourage you that nothing is impossible. So the outline of this talk is, I am going to talk about some Pune University days, my colleagues and friends, some of them are already here, they join. I will also give you a glimpse. What are the most valuable things in life? And then what can we do when we have good direction? Direction with the help of gurus who teaches us. I will also talk a little bit about a Guinness World Record and a glimpse on what we are doing currently in our research group. And there will be plenty of time for you to ask questions. So if I ask you a very simple question, what is the most important or valuable thing in life? Does anybody want to say something?
Satisfaction.
A college dates.
Good.
Time.
So the important thing in life is education, according to me. Once you have education, enough fundamental background, you can do remarkable thing during your life journey. You don't need to have property from your parents or anybody else. You can make it, and only that can happen if you have a good fundamental education. So who are our first gurus? First gurus are our parents, who really put hard work and put us in a school. And even we are not in the school, that time they are the one teaching us to talk, teaching us to walk. And actually we are defining our pathway of life from the time we are born. And they are the first gurus. And as strong as their direction is, we will be successful in life. So my first gurus were my parents, my father and mother. They are not anymore, but they were the one put me in a path saying that nothing is impossible for you. You can fly really high. So in education, what you are going to get is knowledge, righteousness, and courage. And once you have that strong boost from your parents, then I think you can take off and do the remarkable things in your life. Now, the second gurus in our life are teachers. And those teachers can be from your elementary school, your middle school, your college days, or university days. They have a remarkable job to strengthen you mentally, physically, to take the challenges that our world will be putting in front of us. This is the school in Pansarwadi where I was educated, where we had only 2 classrooms. First and second grade was together, and third and fourth grade was together. We had only 2 teachers there, and they used to teach there. Then I went to Gadge Maharaj Vidyalaya, that is in Otur, 100 kilometers north towards Nashik, where I completed my high school. Then I went to Anna Sahib Wagare College, Othur, and then came to Pune University. So along really there was a significant role of teacher that gave a direction that you did good job in high school, you should go to the college, you should be taking science and not the arts. And then the college teacher said that, oh, you did very well, you are first in the college now, you can go to the Pune University and you can do MSc in an autonomous center, which was rough that time. But I do feel that it did pay me back the days I had in Pune University between 94 to 2000. That was really a good time of my life. I could do very well after that. So the journey began from Pune University. This is the place behind the university tower. I used to go and sit in the afternoon in between classes, thinking about it, where I am heading, exactly what I am doing. And sometimes I used to have answers, sometimes I don't have answer, because just doing MSc and there are different things to do after MSc. But then I realized that I should be doing PhD, that is the highest degree in education. And once I have that, the life should be better. And then I started actually PhD in Pune University itself back in 1999. But I was the one to choose to do PhD in nanoscience and nanotechnology. And then I started feeling that there are no enough facilities around here to really pursue that. And that made me to take off and go to Israel. This is a Bar Ilan University picture where I did my PhD and first postdoctoral research. Then that became very successful. On that basis, I was selected at Argonne National Lab as an Argonne Scholar. They select only 3 people around the globe per year to make a next generation scientist. And I was selected one of them where I was working on neutron scattering. And then followed by that, 7 years of service I paid to Argonne National Lab and moved to Purdue University. One thing you will see in this picture is all the universities I have been, either that is Pune University or Bar Ilan or Purdue, all of us, we have a tower. And that tower is telling us that fly high. And that could be the reason that all the universities have particular towers, and that could be a memorandum from them to take and get benefited with the education and use that education for the societal benefit. So while learning, my guidance was from my PhD professor, Ahran Gedanken. He is the great material scientist in the world. I did my PhD in sonochemistry, where the ultrasounds were used to make the nanomaterials for a variety of applications. For example, we made the materials that was used in magnetic storage, data storage, solar cells, in batteries, superconductivity. So we made so many materials in nanoscience and studied their initial properties. For example, that time everybody used to say that nanomaterials has different properties than bulk. So what are those properties? For example, the gold, the melting point of gold is 1065 degrees Celsius. But if you can make very tiny nanoparticle, let's say 2 nanometer, that gold melts at 196 degrees Celsius. There is a Oswald ripening things happening with very small amount of energy, as most of the atoms are on the surface and the gold can melt. So those type of properties I was studying back in 2001 to 4. Then I came across Professor Doron Arbach. He's a great electrochemist on this earth, remarkable electrochemistry he developed from Israel. Many companies are utilizing it. And that exposure I got during my PhD. Then in the same department, chemistry department, Ari Zaban was the first graduate student of Professor Doran Arbach. Now he is a vice president of the University of Barilan, with whom I got exposure to dye-sensitized solar cells. And that work was done between 2005 to 6. And with around 40 publications from Israel during that 5 years of time, I got selected at Argonne National Lab, where I came across Dr. Michael Thackeray. He is a great electrochemist again. He did remarkable cathode work for lithium-ion batteries, and he did work directly with the Nobel Prize winning people who got 2019 Chemistry Nobel Prize for batteries, lithium-ion batteries. And the journey continued, but their impact in my life is still live, and because of that, I could do what I am doing currently. So everybody knows this world map. This is the place I am born and brought up in Pune University. Israel is very, very tiny country in the world. When I had to go to Israel, I had to really find out where is Israel on this map. And we used to go through this small channel of water to Israel here. And really it is a small dot on earth. The area of Israel is half of the Maharashtra area. Whole country you can visit in the whole day with a four-wheeler car. And that took me off, and then I went to Chicago area, which is somewhere here, where I am located now. Indiana is next state to Illinois, where Purdue University is located. You might be aware of these facts and figures, but just to elaborate that, we do have a significant impact and global map. Pune University is known to be one of the largest university in the world. We have 500,000 students. That includes all your college students from different areas. Purdue has 50,000 students only. Comparatively, Pune University is really big. We do have 52 postgraduate departments. When you are there, you don't have value for that. But when you come out and look back, it is a really a significant benefit for all Indians to go to Pune University and learn. There are so many colleges around Pune, and there are students from 102 countries in Pune University. I came to know that when I left India, but there are only 196 countries in the world, and more than half of the countries are getting educated in Pune universities. And world ranking is also pretty good. Where I had a pleasure to complete my 3 degrees, Bachelor of Science in Chemistry, Master of Science in Inorganic Chemistry, and MPhil in Physical Chemistry. And really that gave me enormous strength to do the things I am doing currently. You might realize that once you are in Pune University campus, every year there is a convocation ceremony. You say Padvi Pradhan ceremony. That time I had a chance to take a picture and keep them. So Bachelor of Science, Master of Science, and MPhil did happen in Pune University. And I am really proud that I got educated under the gurus that I had at Pune University. Those are the colleagues and memories still I have. I went to chemistry webpage. I have a classmate there. She is now teaching and researching. I have some seniors. And I had some colleagues in Nikum's lab who were there. They were my boost that time that, Vilas, you can do it. Go ahead, we will help you out. You may or may not know that while going to Israel to buy a flight ticket, my colleagues supported me that time. So altogether, it was a very good journey. And then with those memories, I could go to Israel. It happened that I could go back to Pune University back in 2017, there was a talk organized by Professor Nikhil's group and others where
हा 45 चला आम्ही पण निघलो मुली हा
So in Pune University, I gave a talk back in 2017, and I could see the new building that came up, and that is there now doing remarkable job, educating students, give hands-on experience, which is really important. That tells you that how the theory works. Otherwise, many times, fundamentally, we are very strong, but when it comes to apply that knowledge, it gets difficult. But I think Pune University and particularly chemistry department is doing very well, educating student and making a next generation brighter and brighter. Anand Meher and some of my colleagues, our classmates, also organized a get-together in 2016 when I visited India, and many of the inorganic chemistry, organic chemists sitting here in one of the restaurant, and we had a very good time when I visited India back in 2016. So what happened to me that I am going to showcase, and what gave me the direction to go worldwide. So actually, when I did complete my MSc in 1996, I got apprenticeship at Hindustan Antibiotics. As you know that Hindustan Antibiotics was the first company to produce antibiotics for whole India, and I think still the case. And I was not afraid to become apprentice and learn from them. I was assigned as a chemical plant operator. The fermenter has a 90,000 liter capacity, and we used to put a lot of acid or bases, so control the pH. Not necessarily I was understanding everything what I am doing, but with the help of seniors, we were doing it. And the initial goal was to become a scientist at Hindustan Antibiotics, so with the MSc background I had. But the destiny was not saying that. There was something else in mind. So the Hindustan Antibiotics became a CP back in 1999, and they did not make me permanent. And actually they said, leave the company as soon as possible. I completed an apprentice program there, and then I moved on. But during that time, I was doing MPhil with Professor Dedgavkar on rocket propellants. And that made me to go to High Energy Materials Research Lab, which is located in Pashan, where Dr. Abdul Kalam used to develop Agni-Nak, Pinaka missiles and rocket propellants needed for that. So based on my MPhil background, they selected me to work at HEMRL. And then I used to go back and forth to HEMRL, learn more and see how the rocket propellant works. And that was the time I came across
विलास यांचा आवाज येत नाहीये. हॅलो.
not
audible, not audible. So just hold a mic. I think you're not audible.
oh. Now is it okay?
Yes, it is okay, sir. Go ahead.
Yeah, no.
Thank you for letting me know. So I was talking about High Energy Materials Research Lab, where I was working for 18 months after my Hindustan Antibiotics work, where I got involved in Kabaddi. You might know that there are 51 laboratories of DRDO in India. They are in various places. There are several in Pune itself. So HEMRL is one of the department where we used to make and still making high energy materials for a variety of reasons. So I was the gold medalist for the kabaddi that time, pretty young, a lot of energy. And they used to give me work, but I used to finish early. And they said that to use some of your energy, you should be playing kabaddi. And I did that. And among all those 51 labs, particularly in 2001, HEMRL was the first one in kabaddi. And I still have this gold medal hanging in my office, giving me strength, saying that in India, it is very difficult. It is very competitive, but you did play kabaddi, and that yield a gold medal for you. So it happened that 1999, when I was supposed to become a permanent, or in 2000 at HEMRL, that time also the government rules changed and they said that we will not make you permanent. And I had to go out of the HEMRL, and I came back to Pune University again and decided to do PhD in chemistry, and I got registered, but I wanted to do it in nanotechnology. It started having the difficulties to complete the PhD. So then I moved to Israel, where need is a mother of discovery. आपल्याकडे म्हण आहे, गरज ही शोधाची जननी आहे. The गरज त्यावेळेला अशी होती की I need to do research work in nanoscience and nanotechnology, and I couldn't do that very effectively. Then the imagination came that there are ways to do it. And if you are enough creative and innovative, then the various discoveries could happen. And with that, I indeed moved to Israel to do my PhD. So what is creativity? Everybody is creative in the world, but according to late Abdul Kalam, his definition of creativity is seeing the same thing but thinking differently. And that is the difference actually everywhere in the world. Everybody is doing research work in any topic, but the way they look at it is different. And people do have very big, giant goal in front of them, and that makes them very creative to take that challenge and solve that problem. So this is a picture of Bar Ilan University you have seen. It is a Jewish university where only the Jewish people, Hebrew language, even their PhD thesis is written in Hebrew today. In that university, I got admitted, where there were several difficulties. Namely, I had to sit in the class where they are teaching in Hebrew. I could not really understand what they are talking about. I used to see x-axis and y-axis and make some sense out of it. And I told them that give me English books and let me know that what book from which you are teaching, and I will be writing English answer sheet. If you can grade that, then I will be able to pass your 16 courses. And I did that way. So my MSc and MPhil background was enough strong, where I learned chemistry very well and could pass their very hard courses, although they taught it in different language, but I wrote it in English and passed. And then focused on research. So when I was doing a PhD, that time, how to write a thesis in Hebrew, that was also a issue. So my supervisor, Dr. Garan, was the head of the department. He said that you can write a...
कुंभार सर, सगळ्यांचे आवाज म्यूट करा.
So eventually in Bar Ilan University, my supervisor told me, you write a paper thesis. What is paper thesis? You publish 3 or more articles and you will get PhD. So in 3 years and 3 months, I published 9 articles in Pretty Good Impact Factor Journal, and 10th was submitted. And then they said, you will have your PhD and you can move on as a postdoc. So Professor Gedanken and his wife, including my parents, came to Israel during my PhD graduation, and I got a PhD in 2005. That made me to move, do a little bit research work on a dye-sensitized solar cell because my spouse was completing PhD in the same university. And after she completed her PhD, we all together moved to Argonne National Lab, which is in Chicago area. That is the first national lab of United States. They have X-ray beamlines where unique discoveries are happening. For example, there was a Nobel Prize on DNA, RNA structure analysis that was owned by one of the Israeli lady. But that X-ray was taken at Argonne National Lab in 1972. And thereafter, multiple things happened. So I was appointed as a material scientist in that lab for 7 years. And then Purdue asked me to come to Purdue and join and open an experimental research group in energy storage. And that did happen. So while doing all this, I was looking at the problems differently. For example, we do have this plastic waste recycling problem. Plastic discovery is remarkable, but the amount of issues it is creating to humanity is terrible. As you can see that there are grocery bags and water bottles and Coke bottles everywhere. So we are trying to figure out what can we do with such material, which are really useless after 1 use or 2 use. So one of the reactor I could develop that time was plastic waste upcycling reactor, where I used to take plastic, and my idea was not to recycle, because plastic typically you can recycle 1 or 2 times and thereafter you cannot recycle. So what you can do is, I was thinking to break down the chemical bond between carbon, hydrogen, and if there is oxygen, and hold all that together to make something out of it, but that should have very high value and not the same value. So when you break down the carbon hydrogen bonds, for example, from polyethylene, the hydrogen remains a gas at high temperature, and you can have the carbon in a liquid state. We can call it as a liquid crystal, and you can nucleate it. And actually we could make very unique form of carbon that is a spherical carbon back in 2005 and 6. And that carbon has very unique properties. Carbon is really stable, so it can be a lubricant where it can act as a ball bearing. So we use this carbon in a variety of technologies, including lithium-ion batteries and lubrication, tire industry. And actually in 2015, this technology won a R&D 100 awards. That means only 100 technologies around the globe people get that award, and one of this technology was chosen that time because we can make something unique out of this plastic waste. If you are generous, we can add a little bit catalyst in the reactor, and you can make carbon nanotubes. That time carbon nanotubes was very hot field, and we were believing it can change the world, and we will have many applications. And we could make it just from the trashed plastic bags in a very simple manner. I will not show you this video. There are multiple videos on YouTube. You can find that checking my name. That work was highlighted on Nova Science, which is a channel of PBS, where you can see the scientific discoveries highlighted and their unique applications. So if you remember the quote from Mahatma Gandhi, he mentioned at some point, I have the belief that I can do it. I shall surely acquire the capacity to do it, even if I may not have it at the beginning. In simple terms, in the beginning, you will not have the strength required to complete the task, but you should have a belief that you can do it, and with that, you will be able to achieve. So going back to our gurus, I never dreamed myself that I will be a teacher, because my family background was a farmer's family background, and I never thought that I will be teaching at a university at some point. But scenario go on changing. Life took me or gave me different directions. And finally, I landed here at Purdue University, where I became a teacher, where the world ranking of these universities are really high. Engineering departments are really doing well. Some of our departments, for example, our agriculture department is #1 in the country for many years. And actually, Purdue is a person, or his surname was Purdue. His dream was to have a better agriculture happening in the US, as Indiana has a lot of flat land. They produce a lot of corn. So what can we do with the corn? And his idea was to do something remarkable things. But then all other engineering colleges came in, and eventually it is one of the leading university educating lots of people, including lots of Asian and foreigners in this university. So at Purdue University, as I briefly mentioned, Neil Armstrong was graduated, and then he went on Apollo 11 in 1969. He graduated in 1965. And that time, Neil Armstrong, when he put his first step on the moon, he mentioned that that's one small step for a man, but one giant leap for mankind. And thereafter, Purdue University started creating more astronauts, and I think current number is 23 or so. So they are going to different planets and exploring what is going on around the globe. It happened that Dr. C.N.R. Rao, Bharat Ratna, he also visited Purdue, and actually his graduation or PhD is from Purdue University back in 1958. So I got to meet to him and host him at Purdue University when I joined back in 2014. And we had very good time, and he was telling his nice memories from Purdue University. Now I'm going to take you to, that was all my journey, but that helped me to begin others' journey. For example, this is my research group, where they are working on a variety of topics in energy storage. Although the battery looks like a one topic, but battery has electrolyte, electrodes, separators, packing materials, and many other aspects, their safety aspects. So my team is involved to make a variety of materials for the safer, longer lasting batteries. And you can see that it is a multidisciplinary team, people from India, China, Japan, Korea, all the people from all over the world, they are involved to do the research work. And actually, that does help remarkably, because everybody comes from different background currently, and we could solve very unique problems that is really hampering us currently. Technologies are not working, but we could make them work. So as I mentioned, my team works on energy storage or batteries. There are several challenges, and we are not solving one challenge. We are taking care of all the challenges together and then developing technologies. Otherwise, many times when we do research, we try to solve one problem, but create the other problem, and then the technology never comes to the market. For example, to make your batteries better, you have to have the battery cost lower. Batteries should be safer. They are not safe. They will not be safe as they are holding a huge amount of energy. Typically, life of your laptop batteries or cell phone batteries are 3 to 5 years. And we would like to have the batteries that would last, for example, in electric vehicles for 15 years. And one of the reasons batteries are not having that long life is the electrolyte sitting inside the battery is highly acidic. The pH is 2, just like Coca-Cola. and you put anything in that pH, acidic pH, it is going to deteriorate. And that's why battery life is really limited. So you have to come up with a materials architecture. How can we avoid that corrosion that would have a longer life of the batteries? Batteries are just like us. They like the room temperature operation, but at low temperature or high temperature, the batteries are not operating very well. Where at low temperature, we call it as cold cranking. Electrolyte freezes, the lithium dendrite growth happens, and the battery may not work. And now we are 7.77 billion people on Earth holding 15 billion batteries. And the recycling became a bigger problem. Now we have to really look at this battery technology altogether and solve that problem. Otherwise, we are generating more and more batteries, just like plastic, and we do not know how to get rid of it. So my team really think about all the aspects or challenges of those batteries, and then make the new type of battery that could solve most of it. Otherwise, the future can be looking like this broken glass. So what do we do exactly in my group? So there are a variety of batteries. Typically, currently your cell phone and laptop is holding lithium-ion batteries. But there are next generation batteries such as sodium. Sodium is abundant and inexpensive everywhere in the world. Same thing with potassium. There is a high energy density batteries we are talking about around the globe now on lithium sulfur system or solid state batteries. So my team does work on a variety of aspects of the batteries, but the main focus is whatever technology people are developing or we are developing, it should be safer than today. If the batteries are not safe, then we are not going to utilize that in any device. So we call it as Purdue University Battery Systems Lab, where we are developing the pouch cell that sits in your laptop or cell phone, and then test its reliability. So we start all the way fundamental from materials aspect, electrolyte aspects, make the batteries in a small coin cell type, and eventually make, with the help of industries, a larger pouch cell, and then checks its durability and safety aspect in a variety of devices. And my group is funded with typically National Science Foundation, NASA, Office of Naval Research, DOE, and many other funding agencies, including some of the industries. Now, I am not going to give you a talk on research here, but to encourage you, there are some golden words from our own people, where Dr. Abdul Kalam used to tell us, what is the success mean? And how can you achieve? He also came with very remote background and eventually did very well in his life. And he was the excellent teacher. And he took his last breath when he was teaching. So teacher really does a significant job and valuable education we get, and they are our gurus. So what was he saying is, you should have very high or great aim in your life. If you have a smaller aim, you will do small things. If you have a bigger goal, you will be doing bigger things. So once you define your aim, the second stage you can do is continuously acquire the knowledge in order to fulfill that objective or go towards that objective. Now, just having the goal and acquiring knowledge is not enough. You should work hard. For example, Elon Musk, who is successful to make Tesla and many other things here, such as SpaceX, that is a private industry, but doing so well. So he worked hard. He says, if other people are working 40 hours a week, I work 80 hours, then only I can be competitive to do the things before others. And while doing that, we will be failing many times. And failure is not the last. Failure is the first step to learn. What did we do wrong? What can we learn from that? So we should have a perseverance to do the things again and again. You fail, but you do it. And if you can put all these things together, then you can achieve a great success in your limited lifespan. So that was his overall idea. So giving you an idea that few years ago in 2018, we were celebrating 150th anniversary of the periodic table, which was initiated by Dmitry Mendeleev, a Russian scientist. We were celebrating 150th anniversary. We were also celebrating Mahatma Gandhi's 150th anniversary of his birth. And Purdue University was also celebrating its 150th anniversary from the time it starts. So I was thinking that to fulfill this all, what can I do unique that will teach the students something unique? And actually, if you know the periodic table very well, there are 118 elements in the periodic table. If you understand that well as a chemist, you can do any discovery that is needed for current society. Only thing you need to know all the elements, their places, they are placed in their particular place because of their unique melting point, boiling point, physical properties, atomic number, atomic weight. So if you really understand that, then the discovery is not that difficult. For example, your cell phone that you call it as smartphone today, that almost does everything, including this seminar you might be hearing on the cell phone. So it has an optical capability, it has a magnetic properties, it has a lot of data storage properties. From where did it come? It all came from this periodic table. All the elements, out of these 118 elements, around 60 elements are there, or they're composite in your periodic table, that is making that cell phone, smartphone, and that is really doing much better thing than what we can do. And indeed, you need to know the periodic table. So to do something and teach the student that you need to learn this periodic table first if you want to be a chemist. And then I decided to set a Guinness World Record. Initially, I was teaching the periodic table to my son, who was 7 years old that time. And he learned first 10 elements and then said that it is too hard for me to remember. I don't know what you are talking about. But if you know it, why don't you do it? And you set the Guinness World Record and I will come to see it. He challenged me. I took the challenge, started working on it, and then eventually set the Guinness World Record, where I was actually at a NASA Glenn laboratory giving a talk during July 24 to 6. And Guinness World Record people approached and they said that you can set a record, but you will have to follow our rules. It is not based on your rules. Namely, you will have to have a periodic table that you write by hand and make tiles 2 by 2 inches. That night, I was in the hotel, so I got the paper. I made a small pieces out of that. And I put the element name and started assembling. It took me almost 1 hour to assemble those pieces together to make the periodic table, because once things are mixed, we cannot really separate them out that quickly because our brain is not a supercomputer. And if you misplace one thing, everything is misplaced. You cannot achieve really the way periodic table looks like. So really you need to know who is the neighbor of each element, how it should be. And once you know that, then we can do it. So from July 26th and August 15th, there was not enough time to really prepare for it. So first of all, they tested me whether I know the periodic table or not. So I did write the periodic table by hand. And then there are the tiles here in this particular box, which are also written by hand with the same color, so that I do not have any idea. And I was given a blank table to assemble the periodic table. And then the thing started. I was confident that I can do it. But in the first round, it did not happen. I misplaced some of the elements. And they said that this is not the periodic table, but you get another 2 chances to complete it. Then I analyzed myself what I am doing, which is not correct. That is making me not organize it well. Then second time, I started organizing it. As you can see that your own student became judge, and other colleagues, professors, they came to see this periodic table. The whole university was watching what is happening here. And then eventually I did set the new record. This was the new record that time. There was no record in the periodic table assembly in the Guinness World Record, although they started in 1955. So this was the new record to assemble all the elements of the periodic table in the shortest time. It was completed in the auspicious day for India, August 15, 2018. And I became a first professor of Purdue who has a Guinness World Record on name. To give you an idea, we are 4,500 professors on Purdue campus teaching 50,000 students. My family, including my son, who is here behind the plaque, he is holding it because he said that you got it because of me. It is not your efforts. I told you to do it, and that's why you could do it. And my daughter and spouse joined that time. They didn't go to school, and everybody was enjoying that moment. Now, what are the kids doing? My son named Sankalp, or Sunny, he does chess. He plays basketball, he plays football. And the reason I'm showing you here is actually in early age, we are focusing too much on the education and not the physical fitness. In the United States, people are focusing, are giving an ability to kids to explore all types of games first and see whether they like it or not. So we also allow them to explore everything that is possible, swimming, whatever. Now they are becoming so good in the early age, not to do too much education, but learn how to behave with others, how to be good in the social skill whenever they go to the school. That time they are just learning the social skills. And that is very important, and to become robust and have healthy mindset. And we are allowing them to explore that. My daughter Herschel, she is Indiana State wrestling champion for 3 times. She also stood second in the whole country in her weight group called as Athena National back in 2017. From where did she learn wrestling? So Herschel saw a movie, Dangal, Amir Khan's movie, came out several years ago. So we saw that movie together. That time she was a basketball player, but she decided to do wrestling, as wrestling is a game where you can prove yourself. You don't have to really worry about your teammate, whether they are doing well or not. So she did so well with the background that she got, as I was a wrestler at some point. My father was a good wrestler. We had some wrestling blood, but our Indian wrestling is different than the wrestling happens on the mat. So she learned quickly, and again, in America, there are plenty of facilities. Once you want to do something, there are coaches available, they can train you. And then we used to go to a different place every weekend for her wrestling tournament. Now she is in 12th grade, senior in college, high school, and she will be joining Purdue University in 2022 fall semester. And she wants to become a doctor, MD doctor, brain scientist. And she's working on that. being in the high school or in the college, in the 12th science itself, in summer, she was doing research work in the lab, and she really wanted to become a scientist and doctor and help out the people who has brain-related issues. So again, that is related to kids and family and myself. But what my research team is doing now, that is so unique and different that other people are not trying to do it. So we took a challenge. If we want to go on Mars and make a colony, we might have the sunlight coming there, but what is the energy storing source? If you do not have the energy storing source, you will not be able to live there. So we are making the batteries that can last on Moon or any Mars surface where the temperature could be minus 100, 120 degrees Celsius. So we have to develop the batteries that is working on lower temperature. What vision we got? Neil Armstrong was the first one to go on the moon. So why don't we take the same vision to make the batteries, as we are working on the batteries, that also can work on the moon or Mars, where the temperature is really typical. And first thing we have to solve is to have the energy storing source on those planets. And we took that challenge, and all the students and postdocs and scientists coming from all over the world working on that. Similarly, there are batteries needed for submarines. The temperature could be minus 30 degrees Celsius or so. They need batteries. So we got a NASA project and Office of Naval Research project to develop the batteries for low temperature operations. So just to give a glimpse here, are those batteries working? So we decided to make batteries that can work in a wide temperature range, namely at 50 degrees Celsius, minus 50 degrees Celsius. And this is the capacity versus voltage plot, where how much capacity or energy density you can extract from the battery. And as you can see that these batteries are producing enough capacity. Again, at room temperature, let's say it is producing 160 milliamp hour. At lower temperature, it is producing only half of it. But the current batteries are not working at all. So there should be some battery, the electrolyte should be developed that does not freeze, and there is no impedance developed in the system that will allow to shuttle that lithium ion back and forth during charge and discharge. And as you can see that the red curve says that minus 50 degree, it is working. Now there is a biggest challenge. How can you mimic the Mars surface on Earth? Namely, the temperature on Mars could be minus 120 degrees Celsius. So we are developing a system where we take a liquid nitrogen that has a temperature of minus 196 degrees Celsius. We attenuate that and get the temperature needed, and then make the battery, put it inside and charge and discharge simultaneously, and making sure that batteries are operational. You might know this personality who developed the iPhone in a unique fashion. And his statement was, if you are working on something exciting that you really care about, you don't have to be pushed. The vision will pull you. And similarly, he did so well. The iPhones in everybody's pocket today was developed with this personality. Now, again, going back to the memories, I am here in US. Last year, it happened that another colleague visited me. He is doing in research work in computer science. And then we took a picture with Neil Armstrong. And Ashish is still in my contact, and I think we have a group. We are having fun in between. So he visited my office, and we took a picture in the office as well. And we had a really fun time that bring back the memories that how hard time we had. Some of the courses in chemistry were really rough, but we learned them, we passed them, and they are helping us now to do the things we are doing. So what is the innovation with imagination here? So being a son of farmer, we used to have those ox to race the cart. I was wearing sometimes my army brothers' clothes because there was scarcity of even clothes. That picture was taken in 1992. I was helping my father to do agriculture, tomatoes and cane sugar, bananas, to grow them and sell them to make some money to survive the family. And eventually that farmer's son can become a faculty and who can be chosen as the outstanding faculty at some point. So such things could happen. So with that, I would really like to stop here, and I will give you plenty of time to ask questions. So actually, it is not your parents, it is not your gurus. They are giving you background required, but you are the one to make an impact. You are the one to set a goal and then acquire required knowledge for that, have the perseverance, you will be able to be successful. So we have to be strategic. Anything you want to achieve, you have to plan it well. You might fail, again plan it, execute, and from the failure, you analyze what did go wrong, what can we do that will make it better. And you also need to know what is your strength, what you are good at. Everybody has unique expertise. For example, my students are smarter than me, and I want them to be smarter. But if I can find out their key expertise and allow them to grow in that direction and give some direction, that point of view, they are certainly going to be doing much better than what I can do. So we have to understand our own strength. And if people are working for you, if you are a head of the department or if you are a chairman of a company, you have to understand what are the strengths of your own people. And once you understand that, give the vision to them and they will be able to do very good on that path. You have to believe in yourself. That is very important thing that you should have. Many times we feel that, oh, I am not able to do it because I don't know English, I can't speak. Believe me that first time I talk in English was on the Bombay airport. Before that, always Marathi. Most of early education was in Marathi, and English was my third language to learn. Hebrew was the fourth one. And while doing anything, never give up. Because if it happens, if you can do well, that's fine. If it is not, that is also okay. If you are not able to solve, somebody else will solve the challenge or problems, whatever we have in science and technology that is needed for our society. And there is another member I have in family is our dog, Bella. She go on checking every time that we are perfectly fine and we are doing well. So she take us to walk and good time with family. So with that take-home messages, I am going to stop here and I will be really happy to take your questions.
Thank you. Thank you very much, sir, for this exciting journey from farmer to faculty with a lot of things in between, which you have very aptly presented. So if there are any questions for Dr. Vilas Poet, yeah.
Sir, instead of putting in the chat box, shall I ask direct questions so that
Yes,
we'll have
please,
dialogue
sir.
directly with the
Yes,
Dr. Vilas, sir.
Please.
Yes,
go ahead.
yes. Vilas, it was a really very intuitive lecture for we people. What, okay, you said about your son or your daughter, okay, I'll come to your family or something like that. And they got innovations or something like that. What advice you would like to give for our junior students? Junior students means the students below 15. How they can approach toward the research? In college level where innovative ideas are there, avishkars are there are very wonderful things. But we are starting after 12th or after somewhere around graduation. What advice you would like to give for the so junior people? I mean, say below 12, below 15.
So one thing we have to do is what is happening typically in the high school education, we are teaching them the routine books. And it is good. It is not bad to have that basic fundamental knowledge. But creative thinking, that is the age they are thinking that what they can do. So if we can really place the seed, for example, they are below 50, 12 is the age, 11, 12 is the age where they are really trying to figure out what is happening in the body, what is happening around them. So that is the time we can give them a global perspective of the challenges the society is facing. For example, how the solar cell works. Until we do not understand how the solar cell works,
Right.
how the batteries are working, or how your vehicle is working, how to drive or ride the motorbike. But we are just riding them, but how they are working, really not trying to understand. So if we can ask them to think creatively how things are working or what are the challenges. For example, we are all facing the pollution in Pune, where we have lots of two-wheelers. So even two-wheeler, we are covering our face and eyes and putting helmets and this and that. But even a simple thing you can do is put a flimsy glass in front of you in a way that you do not get all that pollution in front of you. Or can you develop a bike that has a cover, just like a small rickshaw, but then bike is having some shelter that you are not exposed to direct sun, you are not exposed to direct pollution, and you can ride a bike. So when I was sitting in the car and riding in Pune, I was thinking that, see, our skin is getting burned and things are happening, but we are still developing the bikes in a traditional way. We are not changing them. So can someone do that? Again, you have to think about the aerodynamics so that bike will not have too much resistance to go ahead. But in the city life, you cannot run too fast. So you have to drive slowly. So there are ways to...
You rightly indicated that for this research, problem should be there. If problem is there, ultimately, yeah. Right,
there is a problem in front of us, but we have to know, we have to have the eyes and the thoughts to look at it. Because there are problems everywhere, there are problems. For example, when we go to canteen, there is plastic everywhere. If we are a good scientist, why don't we think that what can we do with that plastic? Can we make really something useful? Just I showed one of the example here. Like batteries are dying and we don't know what to do after that. So how to recycle that? Otherwise there is no lithium anymore to use for making future batteries. Or if that is the concern, then there are other elements in the periodic table, what we can take. So that creativity has to be generated, and kids should really learn, oh, I have the cell phone, it is working nicely, but can I do something better than that? So those kind of things.
Thank you, Vilas sir.
Thank you, sir.
We are really proud to be associated with you. Really, thank you. Thank you so much, friend.
Thank you.
Thank you,
Thank you,
Gugum.
Kumar sir.
Anyone
so much.
else?
Thank
Yeah. Always a pleasure to talk.
Dr.
Keep
Vilas'
others on the-
journey is really very exciting and inspiring to the students. Will you please brief them how to proceed if they want to go abroad for further studies?
So actually they are really smarter than us. They know the internet has all the information.
Yeah, but
GRE TOEFL is the basic thing they have to do to approach and go to the good universities. So I am in the PhD committee here. If they want to come for PhD, good school, we look at three things. We look at GRE TOEFL score. We look at their undergrad score, total GPA out of 4 or out of 5, based on you are coming from IIT or university. And any research experience that person has. If they have the research experience, they can save their time during the PhD, help them to do really good things in a shorter time. Time is very valuable, as everybody knows. So we do not want to start from the scratch. And person also should have the creative mindset to do research. Otherwise, we ask someone to do research, or some people are doing research because they want to do something. But this is not the way to do research. You should have a really burning desire to do something. You will find what is required. So I think our current student knows where to find the information. Everything is online. requirements are online, and they can approach to professor, they can write to anyone, or they can call to anyone nowadays, became so easy.
Mhm.
Feel free to
Yeah.
approach me if you
Yeah.
have difficulty. I will be happy to help you out.
Yeah.
Thank you.
Yes, sir. That is also one very important thing. Some inside information or mentorship, which would be helpful, because that is mostly seen as the prerogative of IITs, whereas university students do not have that advantage. So I think that would be a great help for our students, especially those coming from rural areas.
Yeah, so there is a small difference in the education in IITs versus for
Yes.
example, IIT degree is 4 years and our batch typically is for 3 years.
Correct.
So if somebody is coming from university, we look at the master program. If the student has a master done, that is considered then as a bachelor equivalent to US or IITs.
Mm-hmm.
Then such person can get selected for the PhD. But there are many people coming with different plans. Some of them directly come here for master. They pay a little bit amount in the beginning. They get the visa status approved, and then they join PhD. PhD is fully paid by the professors here. That is another route to come here just after bachelor, do master here. There is master program, there is a regular master program, and then join for PhD. And during that time, if they continue to do research, toward the end of their PhD, they are really successful, publishing many articles and really trained for becoming a faculty or doing a very good job in the industry.
Yeah, that's true. Yeah. No, in fact, now I think we are also going to a 4-year bachelor program in the new education policy. So maybe very soon that may happen.
Yes.
And so therefore it will be good for our students. But yeah, we will have to also change our program, the masters especially. So
And
maybe that may be an
now
advantage. Yeah.
you are having the facilities and instrumentation.
Right.
And really, we have to question student, you learn this one, for example, NMR spectroscopy. It is very good to learn in the class, but afterwards, we don't know how to utilize that information. Have an NMR instrument to operate, and they really put the sample in, and then whatever vibrational spectra comes, what to do with that? What does it mean? Or even the we have. What is the diffraction pattern means? What are those planes coming out of? What is the and then how to analyze that? If you give very simple topic, but let them scratch their head, they can really and become a very creative mindset.
Yeah. Several of my colleagues are also there. Pardeshi sir? Yes,
Yeah,
sir.
yes.
You have question, sir? You have something?
Yeah, definitely.
Yes.
Vilas, nice to see you after a long time. And
Namaskar, sir.
Namaste, namaste. I just want to know that you are somewhere in the middle of your career. You have said half part of your journey. I would like to know the full part of your journey. Here we should see Vilas after around 20 more years.
Yes.
Because in your talk, you have said that we should have a vision. That would definitely benefit to our students.
Absolutely. So the glimpse I gave, for example, the last few slides, I was talking about developing batteries that can work at lower temperature. That is so important now to develop such batteries. And indeed, it is the biggest challenge one can face. I will give you an idea. The electrolyte, we have ethylene carbonate based electrolyte sitting in your battery now that freezes at, let's say, minus 10 degrees Celsius. Now, since I took the challenge, I told the student there are some chemicals. They really do not freeze up to minus 135 degrees Celsius. For example, there is a fluorinated compound, just like an oil chain length, long chain length. That compound has a freezing point of minus 135 degrees Celsius. then you add the salt into it, then the freezing point can further go down. But while developing the technology, then you have challenges. Then you should know how to tackle those things. So when I showed a plot that some of the batteries are working where we took such chemicals based on the chemistry background and developed the electrochemistry that could work at that temperature. Now, another factor I said that there is a significant challenge how to test even battery or mimic the Mars environment. So then you bring out some of your physics background and others physics background and learn how you can mimic that, how you can develop that typical, let's say, oven that will take that temperature. You will have to shell out continuously liquid nitrogen. It becomes expensive. But since we decided to do it, the government agencies are supporting us financially. And at some point, I do dream that we will have the batteries that will be the first time working on the different surfaces that includes Moon and Mars. So my vision for myself and other people where nowadays I don't do too many things students are doing. So I just tell them there are really good challenges, but that doesn't mean there is no solution. So I bring the ideas to them and they are the one to execute and see whether it is working. And if it is not working, I tell them it is not the end of the world. It is a good thing. If it could have worked, somebody might have made it work before us. So it is a good challenge to have. Then we can sit together and discuss and figure out what can be done for such challenges, what others are doing. And you do find a solution when you try to really think hard and execute it.
Yeah, in continuation to that, any plan to come back to India?
I am coming back to India in 2022.
Not like this.
To visit you guys.
I'm asking about making the later part of your life in India. Like you said that you had a rough time at university. And then from that rough time, you struggled a lot and went ahead. Now you have achieved many things. So obvious a question, being an Indian and a good friend of yours, we are expecting you. Can we expect you back in India with some good position? A very critical question.
Actually, a very similar question was with IIT director a few years ago. And IIT Indore's director gave me a professorship at IIT Indore where I have a small group and collaboration. So I do work with IITs now on batteries. And again, this topic is becoming more popular. So you guys make a plan and let me know. I will be happy to come back.
Definitely. Definitely.
I think Virat sir is wondering that he has to ask his son also.
So he has not answered the question, but he has given a question to us.
No,
That is
again, there should be some place.
He has thrown the ball in our court.
Yeah, exactly. He has put the goal in our court.
Anyway, thank you.
Thank you, sir. And there is a question from Anuradha. She's asking, according to you, which university can she choose for PhD in organic chemistry? Like Bar Ilan, Tel Aviv, or and Purdue. She wants to do PhD in organic chemistry.
Now, organic chemistry is not a small topic. In organic chemistry, there are so many things one can do, biomed and many things. So actually, whenever you want to choose a PhD topic, instead of just worrying about the university, you should choose a person with whom you want to do the PhD. But that expertise you will be leading in future, or you will be doing better than what professor is doing. So there are 700 plus universities in the US itself. If you find a person that is really doing remarkable job in any field that typical organic field you are dreaming to work on, go with the person, and then university, if ranked university, it is better. If it is not, that doesn't really matter. As my all colleagues here, they are from really reputed universities, Stanford, Harvard, and MIT. Sometimes I feel that from where I came and sitting here, you are the one, if you do well, there is nothing that anybody can stop you, even becoming a faculty at MIT or any other good place. So you choose topic and then faculty and then the university.
Vilas sir, how is Corona scenario in US, in States?
So in United States, Corona, actually we got all vaccinated long back. For example, my lab is open from July itself, full time. Initially, we restricted, make some shifts, but thereafter then we open it. We were teaching one-to-one the whole semester now. The Corona is in control, but you really put a significant efforts, and the whole country is putting and isolating people if they find out that they are infected. The scenario is really under control now. We are outside in the society, living like a day-to-day life without any worry or hassle in mind. So
But
it is
said that especially Americans, they are not supporting the social norms or whatever the government rules are there. They are not following. That's we heard. What is the exact scenario?
So America has a freedom for everyone. This is the one country you do what you want. They will tell you this is not good, that is not good, or this is a rule. But to follow or not, it is you to do it. And that is why people want to be here, because you have freedom to do what you want. So you know the risk you are taking. And you know what risk you are taking. But if you want to go beyond that, you do it. Nobody stops you.
Thank you.
Sir,
Thank you, sir.
Sir, there is a question that by, I think, Phule Harshada. She says that there is some, they have ideas in mind, but don't get way to execute them.
That is not. I did explain to you throughout this talk. You find a solution yourself. You don't say that, oh, I don't have the facilities here. My parents do not have the lab in house. You create it. If there is nothing, then there is a chance to do work on it. So whatever idea you have, tell me at some point. I will give you a direction and we will make it happen. And I don't want any credit. The credit goes to you. I will give you the direction to work on that topic, whatever it could be.
Sir, there is a question by Shovik. He's asking how nanotechnology is related to medicinal or drug chemistry. How can it be related to medicinal or drug chemistry?
Yeah, now nanotechnology, this is very fancy word out in 2000. Actually, everything starts with nano only. The difference was we could not see before 2000, we did not have the high resolution transmission electron microscopy type of instruments where we could not see whether it is nano or not. So when you are talking about the medicinal chemistry, you have to be careful what exactly you are trying to do. For example, if you develop any drug that has a nanoparticle, will our body take it or not? We have arteries and veins. So what is the diameter of that? What is the particle diameter? Is it going to block it? Is it going to create another problem? So whatever people are saying that nanoparticles or platinum nanoparticle can cure this and that, but we have to be careful what could be the side effect of that metallic body or oxide body sitting in your body. And there should be a lot of work has to be done before we release anything related to nano for the medicinal chemistry.
Okay, are there any more questions? It's nearly 1.5 hours since. Again, maybe we'll take this final question. Maybe.
Yes, hello.
Yes, Domri.
Yeah. Can we work for complete plastic degradation? Is the question that someone is asking. Complete plastic degradation.
This is a very nice question, which can have very long answer, but I will try to make it short. First of all, when you say plastic, plastic is so robust. Any plastic, let's say polyethylene or polypropylene or polyethylene terephthalate Coke bottle, water bottle, it can hold acid, it can hold the base, and it does not degrade. So carbon hydrogen bonds are aligned in a way that does not degrade with acid or even base. So to do the complete degradation, you will have to do something to break down the chemical bonds. For example, when you are trying to recycle the plastic, what we are doing is the plastic, we put it together, we melt it around 180 degrees Celsius or 200 degrees Celsius, and we mix it up, extrude again to make another plastic. That is recycling. But when you say complete degradation, that means you don't want that plastic anymore as a plastic. You want to get rid of it. Now this bigger plastic bottle can become small, and become a particles, and those particles can go everywhere. So it's not a good degradation, because eventually that plastic will land in your water flow. And actually we are drinking this bottled water, it is not a good thing. The reason is when they produce the water bottle, they never clean it, they just put the water. So there is research done, they said that we are already consuming some microplastics because of the cutting and threading and things happening. So degrading plastic naturally is not a good thing, because it will go to your water flow and eventually harm our ecosystem, including the animals in the sea. But the other approach one can think, like I was talking about, you break down the carbon hydrogen bond, you get that carbon back, and you put hydrogen in the cylinder to utilize. Currently, you are all people making carbon. Carbon is there in your printer toner industry. All your car tires are black because there is 30% carbon added. That carbon dissipate the heat, throw it in the air, and allow you to go. So carbon has tremendous amount of application. The carbon typically is made from hydrocarbons or petroleum gases. So why do you burn the petroleum to make the carbon? You can take this plastic, make the carbon out of it. So you take something waste, make something value added product, and at the same time store that hydrogen gas and utilize it for a variety of purposes. So this is the only way one can completely degrade it. So the process we developed at Argonne National Laboratory was high temperature, high pressure, where you can make unique form of carbon products out of the plastic. So we have to come up with such ways. Even the bacteria can degrade it, but it takes forever. Even nowadays, there are cups came to the market, they say biodegradable. But actually problem is still the problem. If there is a biodegradable cup, how can you put the water and it is not degrading? Or it is holding the water or hot coffee. So they put the plastic layer inside that cup, and we see the outside portion, it looks like a paper cup. But in the paper, you cannot hold the water or hot tea. So they did some magic inside and then saying something to the market, but we have to really see, is it degradable? So the only way, according to me, to completely degrade plastic is to break down the chemical bonds and get rid of plastic. You don't have to recycle the plastic, because making plastic is very cheap and we will be making it again and again from new source. So why you want to recycle? You should just decompose or dissociate the carbon hydrogen bonds, get the carbon out of it. And that I have a TED talk, you can see on the YouTube how it can be done to get rid of plastic.
Okay. Maybe a last question from me before we end this talk is, what difference do you see between the students, maybe master's students, because you have seen the University of Pune and affiliated colleges. You have also seen the Bar-Ilan University students, and also students at the US universities, including, I mean, obviously Purdue and Argonne National. What difference do you see especially in their education attitude towards like research or?
I will answer it slightly differently.
Yes.
So actually, the people who has a scarcity, जसं आपण म्हणत होतो गरज ही शोधाची जननी आहे, more the scarcity you have, more the successful you are. The people coming from our rural background, Pune or whatever area from India, or throughout the India, so many professors came to US or people came as a student here, and they are becoming much more successful professor than other faculties who are born and brought up here. And the only reason I find behind it is we had this jugaad technology that we never give up on anything.
Exactly.
We try to find out what can I do with whatever I have. If you get everything near you, then you do not become creative because you have everything. For example, if my father had everything that I could do research there itself, then why did I come here? So when I do not have something, I try to find it. So similar way, the student can be from India or Israel, from US. More the less things they have, more creative they become. For example, as I said, if you have knowledge, you don't need anybody's property. You can make billions of dollars of property on this earth. I have my colleagues here, they are the one to pay my air ticket to Israel. I didn't have that 21,000 rupees that time. So, and that was a good thing. I remember that, and that really helped me. Even after getting lots of money now, I try to use that money effectively in a good purpose. I am not wasting money. I am not putting it anywhere else. So the scarcity really helps you to become a better person.
Right. Okay, I think I don't see any questions, and now it's yes. Tumre sir, bola.
Yes.
Before we
Kumar
end. हा बोला सर.
मी एकच मिनिटात फक्त एक्सप्लेन करेल आता. ज्यांनी आपल्याला हे टॉक दिलं ते विलास पोळ, माझ्या म्हणजे आम्ही थोडक्यात आपल्या भाषेमध्ये, मराठी भाषेमध्ये ज्याला आपण म्हणतो ना बांध भाऊ, शेतकऱ्यांचं कसे असते, एक दुसऱ्याचा शेजारी शेत असेल तर बांध असतो मध्ये, आणि आम्ही बांध भाऊ आहोत थोडक्यात. ओके, वन थिंग. सेकंड थिंग, याचा प्रवास म्हणजे आता याचा म्हणजे यांचा, आता तो माझ्यापेक्षा लहान असल्यामुळे मी याला याचाच म्हणतो, तो मला दादा म्हणतो. तर याचा प्रवास हा, याची जी जर्नी आहे, ही जर्नी मी सगळी हा जेव्हा काही मला सांगतो त्यावेळेस मी ती लिहून ठेवली, आणि त्याच्या मी असे पार्ट मध्ये सगळे त्याचे व्हॉल्यूम केलेत म्हणूया आपण त्याला. ओके, कुंभार सर, तुमचा फक्त एक नंबर सांगा मला, म्हणजे मी माझं इथं टॉक संपवतो.
सर मी तुम्हाला शेअर करतो, तुमचा नंबर मिळालाय मला.
येस, ओके ओके.
नाही, आणि वी विश दॅट मेनी other students from our department, affiliated colleges also have a similar journey and help to solve problems, major problems that the world is going to face in the future. And we would like to take this opportunity to thank Dr. Vilas Pohl for joining us in this webinar, which we have very aptly titled Memories and Dreams. And he has also shown us all the memories that he has of the department, of right from his school, and also the dreams that our students have to try to follow his path, follow similar paths, and do something different. And therefore, we would like to take this opportunity to thank Paul sir for coming once again. And we hope to see him in future in person in the department, again talking to our students, motivating them for their future endeavors. Thank you very much. And I also take this opportunity to thank all the participants for joining us on this second webinar. We hope to see you soon next year. And I take this opportunity to wish all of you a happy Christmas and happy New Year again. Thank you very much. Good luck. Goodbye.
Yes, thank you. Bye.
Very nice.
Bye.
Very nice.
Thank you very much.
And good evening. Yes. Thank you very much.
Good evening. Happy New Year to all. Thank you, sir.
Thank you.
Thank you. Vilas sir, कसे आहात? विलास सर कसे आहात? आता मराठी आपलं होतं ती भाषा. That's it. Good.
Vilas.
Yeah.
पवार सर बोला.
हा म्हणलं झाला की तो आवाज जात नाही वाटतं ना.
नाही येतोय ना.
येतोय ना, ठीक आहे. त्याला म्हणलं आता किती वाजले तिकडे बाबा, आता सकाळी सुरुवात बिगिनिंग झाली असेल त्यांच्याकडे.
8 वाजले असतील आता. 8
8
8:30
वाजून
8 वाजून
20 मिनिटं झाले.
आता ऑफिसला
ऑफिसला
आज
जायचं
सुट्टी
असेल.
नाही, इकडे
आज सुट्टी आहे का
क्रिसमस
सर?
सुरू आहे. हो, क्रिसमसची सुट्टी आहे.
सुट्टी आहे का? अरे वा, मस्त. एन्जॉय. बरं या, परत आले या आता.
शुअर सर. ओके, थँक्यू व्हेरी मच.
Yes, thank you.
Thank you.
Yes, yes.